All right. We have a lot to cover in the next 30 minutes. We're going to try and keep it to 30 minutes. We may go a little long this morning, but I'm just going to go ahead and jump right in as people are still filtering in because we have quite a bit of material to get through for this month's press briefing. So, Robert, if you want to just quickly jump to the next slide. Um, Welcome. We are Berkeley Earth. It was a slightly updated intro slide for this month's presentation, but it's just a little bit about us. We are a very small team. You can see everyone on the team is joining us this morning. I'm Kristen Sissener, Executive Director. We have Robert Rohde, our Chief Scientist, Zeke Housefather, Research Scientist, and of course, Kate Viscara, who helps keep all the trains running on time behind the scenes. And we're grateful to have her help. Um, Next slide. So not going to go into detail about the slide, but this is just a little bit about our products and our product stack, starting from our old school observational record, our current high resolution product. Last week we previewed our new product synthesis. We'll have more information coming out about that soon. And you will also see some additional material from that platform and our new warming projections and some of the metrics as we get into talking about the European heat wave and what that means going forwards. But again, we will have more information about synthesis to share via our mailing list, as well as our public channels very, very soon as we tie up the remaining loose ends on getting that ready. Next slide. And as always, the material that you will see in today's presentation, the majority of the material from our monthly temperature updates is made using our high resolution product. This is available at a quarter degree resolution. Kate just dropped the link into chat there to access that product. As we transition forward to synthesis in the coming weeks and months, much of the material and the data from our high-res product will also be available on the new platform. So some more information is available there for the time being. That is by request through that request form that's in the chat. And I think that's it. Just a couple quick housekeeping notes. We will, as always, record this call. We will make the slides available. Just a note that the report this month is just a tiny bit delayed as we have a few more details we need to finalize in that. That will go out later this evening, Central European time, and we will send out an email probably sometime tomorrow with that report. So apologies for not having that available, but you will be able to get the bulk of the information from this presentation. So Robert, I will pass to you to get started. Oh, sorry, Q&A. Q&A, put your questions in the Q&A box, and we'll get to as many of those as we can. Okay, now I'm done.
Okay, so welcome everyone. So this press briefing will discuss May temperatures in a climate change context, but it will also be a little bit forward-looking, and it'll also have a extended discussion about what is currently going on in Europe with the heat wave. So let me dive right into it. So we'll start with looking back at May and where we are in climate in 2026. May was nominally the second warmest May since records began in 1850, 1.35 C above the 1850 to 1900 average. Behind the record in 2024, slightly ahead of 2025, and noticeably warmer than any May prior to 2024. If you look at the month-to-month ticks, now looking at all the months, not just the Mays, May ticked down slightly from April. We're actually a little bit below the trend line at present, close to it, but a little bit below. Similar to January of this year or some of the months in the last end part of 2025. We're still well off the highs of the El Nino peaks in 2023, 2024. So another way of seeing this, we have, each line is now a year and showing the months. We've been running mostly third or fourth place in 2026, behind the records in 2024, 2025, sometimes behind an additional year, but around third or fourth place overall. It's still one of the warmest years on record, warmest year since we've measured. but it has a little bit of catching up to do if it were trying to set a new record overall. May had broad warmth, which is what we've come to expect in a global warming world. The most unusual features about the temperature map in May are mostly in the oceans, particularly the development of warm areas in the Pacific, with the what is now officially an El Nino event, though actually a weak one. It's actually, I will discuss that a little bit more, but we will talk about El Nino to a significant extent. Uh, Looking at where we had record and near record warmth in May 2026, there was a lot of near record warmth or record warmth in the Pacific associated around the El Nino areas and a little and to the north of them. There was also, warmth in southern hemisphere oceans, a little bit in the Atlantic, a little bit around the margins of Europe. There was not so much record warmth in on land. We only had less than 1% of land areas having a locally record warm May average, which is this is actually fairly unusual. Usually the ocean and land are similar. This time around, land was did not have that many records. Uh, Land in 2026, similar to 2025, but also similar to several other previous years. It's nominally third, but it's sort of tied with, fourth, fifth, sixth, all in there. And it's below the record in 2024. And again, and looking at land on a month-to-month basis, we've ticked down. We are noticeably below the long-term average on land. Uh, Sort of in a little bit of a cooling dip after the warmth in the previous years. In the oceans, we nominally were second, but effectively tied for first with 2024, uh, with the uncertainties there. And as I said a moment ago, 5.8% of ocean surface had locally record warm May conditions. On a tick-to-tick basis, we have been trending upwards as El Nino is developing, though May ticked down with a somewhat large uncertainty because of the preliminary nature of the May results. But we are expecting overall a upward trend as El Nino develops and strengthens. So let's talk about El Nino. So we were in a double dip La Nina in 2025 and the early months of 2026. This has now ended, and we have transitioned rapidly towards an El Nino event. Officially, we're in a weak El Nino state in May. Part of that is due to a lot of warmth being deflected north of the traditional El Nino zone, but we're expecting this to rapidly intensify. That El Nino is going to develop, and in the coming months, we will expect this to transition towards a strong or very strong event, possibly the strongest El Nino on record. Which oh, and here is the map. If you very keen eyes, you can see that the equator is a little bit is sort of just below the warmth in the center part. So we're just we're not quite catching it, which is why we're sort of weak at the moment. But that should develop quite soon. I would also note that this warm patch off the coast of North America, which has been there for a few months now, it's not present in every El Nino, but is obviously likely in this one. It's also reminiscent of the El Nino we saw in, I believe this is 2015, 2016, that had a similar structure. So that's a fairly strong, that's probably a better analog for what we may see in coming months, with this warm patch off to North America affecting, U.S. weather, as well as the El Nino developing in the Pacific. So turning now to what NOAA has said about El Nino forecasting. This is a combination of models and human judgment goes into their forecast. They're expecting a very strong El Nino to develop with about a 60% likelihood, and a strong or very strong El Nino with a 90% likelihood before the end of this year. And I'll discuss a little bit about the modeling results in a moment. But we are anticipating, a very substantial El Nino is coming soon. This will increase temperatures in 2026 in the later months, though we anticipate the effect will be much more dramatic in 2027 global averages than it is in 2026. Uh, so now I want to give a little context to what the forecast models for El Nino are telling us and how it compares to historical events. So on the top part of this graph, you have 13 forecast model ensembles that are doing seasonal scale forecasting and trying to predict the future El Nino state. On the bottom part, we have historical El Nino events, the 10 strongest historical El Nino events, measured by this relative oceanic Nino index, which is essentially a temperature in the Central Pacific adjusted by the average temperature in the tropics. Uh, and what we find in the models is that most of them are going higher than 2C, indicating what is a very strong or sometimes called super El Nino. So 11 of 13 forecast models are indicating for a super El Nino before the end of the year. 7 of the 13 models push this so high that they are forecasting something stronger than any El Nino we've ever observed. That's a pretty remarkable place to be. We don't typically have forecast ensembles where a large portion of it is beyond any historical event, but that's where we are right now. There's very wide uncertainty here. There's obviously substantial model disagreement. I would tend to discount the models that are way up at 4+ degrees Celsius. I don't think that's physically plausible. But I think we do have to consider a very real chance that we are looking at an El Nino event that will be the strongest in modern history. Or if not, then clearly among the top events. We will have to see how that plays out over coming months. A few months from now, we should see the models coalesce substantially about what they expect to happen. It's a bit hard to do end of year forecasts from May and June, but we will see where we are. It could be a very significant event. uh, so just to say where the global trend is going, that the headline actually should say 2.5%, not 5%. I apologize for the typo. Um, we right now we have been trending third or fourth warmest in most of the previous months. Uh, there's probably the forecast model that we use thinks there is not enough time for an El Nino to develop and raise the temperature to the point that we catch 2024 and set a record warm year. That's unlikely. It's currently saying 2.5%. Uh, now that is using El Nino forecasting. It's using, NOAA's version, which is less extreme than sort of taking the models directly. So it's possible that this is underestimating how much the El Nino is really going to rev things up. But at the moment, relying on sort of NOAA's forecast and relying on where we are, it doesn't think we will catch 2024 this year. That we probably end up somewhere second or third for the warm, in terms of overall temperature. However, I would say that it's quite likely that if we get a super El Nino or even a strong El Nino at the end of 2026, then 2027 is likely a record year. That warmth, which tends to lag a few months behind the El Nino peak in the Pacific, will translate into a very warm 2027. I do not currently have a numerical forecast, but I think that's where we're heading. All right. Now I want to turn and talk a little bit about the heat wave that's in Europe. So this is a this is a 5-day average of forecast maps. starting back, a few 3 days ago, I believe, starting on Sunday, and looking, for 5-day forecast, finding very large temperature anomalies. So this is a temperature anomaly map across France and also southern UK, northern Spain, some other, extending into other parts of Western Europe. So this is the heat wave that we are currently experiencing in Europe. Centered over France, developing over other parts of Western Europe, has broken a multitude of monthly and all-time records. It is because we are talking about a part of Europe where air conditioning is uncommon, where homes are built for retaining heat rather than being cool. This is a life-threatening event for a lot of people. It's certainly a challenging event, but people who are elderly, people who have, medical conditions, this is a potentially life-threatening event. And it is an event that is strongly influenced by climate change, as I will discuss in a moment. So here is a map for context. This is, yesterday, sorry, is it yesterday or 2 days ago? 2 days ago, map of records set across France, with the diamonds being weather stations setting all-time records and the circles being weather stations setting June, the red circles being weather stations setting June monthly records. And there are hundreds of stations that were setting records in France due to the current heat wave. Uh, and is also, according to the French, the warmest national average was set, the last couple days. Where they're taking many stations and averaging across the whole of France. It was the warmest event in their history. Here is one particular station that set a all-time record. This is taken from the airport in Bordeaux, France. It has about a 100-year record. Uh, I should say 106 years of record. It says 126. My apologies. Uh, so it's about a little bit more than 100 years of measurements were taken in this location outside of Bordeaux, with the last 2 days setting consecutive all-time records at this location and showing a peak well above the expected fluctuation. However, it is notably that this is a new record, but it is less extreme than some of the other recent events we've seen, such as the Pacific Northwest heat wave in 2021 or the February heat wave in the United States. That these deviations are above expectation, but they are not, blasting out the expectations like some of the recent heat waves in other parts of the world have. Now, I will say that this is an event very much facilitated by climate change. If you look at June maximum temperature, which is shown here for Bordeaux, France, the maximum temperature has trended up almost 6 degrees over the last 50 years, which is an enormous amount of trend for something, for a temperature. Obviously, there's fluctuations about that trend. There's probably a little bit of bias associated with urban heat island or other things at this location. We think it's probably about a degree of bias in the Bordeaux airport record. Uh, but there is a lot of warming trend in this location, and there's a lot of warming trend in the extremes in many other European locations as well. uh, the intensity of this heat wave getting up to 42 Celsius in June is likely essentially impossible without the effects of climate change driving up that floor and creating this trend. Also, I would note that the size of this fluctuation is not unusual for Bordeaux relative to the trend. This is roughly a 20-year kind of heat wave in terms of the event structure itself, but it has been lifted dramatically by the effects of climate change to add that record destroying heat on top of it. So events like this are expected to recur in France and this part and Western Europe with a frequency of every 20 years or maybe even less, depending on what you're looking for. This is only June. I didn't calculate the likelihood of it being anytime during summer, so you would have more events then. But yeah, the heat waves like this are going to occur, with some regularity in this part of the world. It's not a standout 100-year event or 500-year event. It's sort of a somewhat common event lifted dramatically by a local climate change. And I will note now that that pattern is somewhat consistent across Western Europe as a whole. We have seen that this now is a trend, a graph showing the change in the average summer day in blue and a change in the warmest summer day in red, averaged across Western Europe. So the extremes, that warmest summer day, has been rising more quickly than the average warmth in summer. This is a fairly unusual behavior. Most of the world is not actually doing this. It's somewhat specific to a few places, including Western Europe, that you are seeing those tails broaden even faster than the mean rate of warming in summer. But that is contributing to the fact that you're getting these extreme heat waves because that tail is being pulled out even wider. I would note that this is something that's already in the literature. It's been studied. This is an example from the Area 5 looking at the Western Europe excess extreme warming trends. And it's very, like I said, it is very much a region-specific kind of anomaly that we see these warming trends in extremes exceeding the summer averages in Western Europe, and specifically France, southern UK, northern Spain, are areas affected. In terms of what's going on, the heat wave in Europe is directly caused by what's called an omega blocking pattern, where you have a very kinked jet stream that surrounding a high pressure system. That high pressure system dries out the air, gets rid of the clouds. You have local heating from increased solar radiation, local heating from downwelling high pressure, and you have wind patterns that are pulling air off of southern France, off of southern Europe, and off of the Sahara, moving that very warm air into Europe. This blocking pattern is the direct cause of the heat wave. We think what appears to be happening in Europe, in Western Europe, is that blocking patterns like this are becoming more common in summer, and that is a dynamical change that's coming on top of the direct effects of climate change, providing warming. And that's why you have sort of these more excess heat wave events. But again, it's still somewhat a issue and discussion in the literature, but that's sort of the view at the moment is that these patterns are becoming somewhat more common as a dynamical change affecting Europe. Uh, Lastly, I would mention that the impacts of this, the impacts of living with a changed world, uh, you know, Europe's not going back. Europe conditions have changed. And this is looking at cooling degree days, which is a measure of cooling load in Paris. Black is an observations, blue is a model trend. These are both data sets provided by our new synthesis platform, which we will be rolling out in the coming days. But the cooling degree load has effectively doubled over the last 40 years in Paris and is expected to double again during the rest of the century if we maintain the current emissions policies. So, places like Paris, like France, like Western Europe need to be prepared to adapt to more frequent, more severe heat waves and figure out what that's going to look like, whether that's air conditioning or whether that's other ways to deal with heat. But the world is different than it was before, and humans must deal with it. Okay. So the full report, we apologize, it's being held for some last minute technical reviews. It will appear at May 2026 temperature update, but it is not available at the moment. And with that done, happy to take some questions.